If behavior doesn't increase, it's not reinforcement. Start there because the BCBA exam won't care what was added or removed. It cares whether the future responding changed. Positive reinforcement is defined by a basic operant functional relation. When a type of behavior is followed by reinforcement, there is an increased future frequency of that type of behavior. That deceptively simple relation requires qualification. The effect depends on the timing between the response and the stimulus change and the stimulus conditions present when the response was emitted and the role of motivation in determining whether the stimulus change functions as reinforcement. Positive reinforcement occurs when a response is followed immediately by the presentation of a stimulus change that increases the future occurrence of similar responses under similar conditions. This is the two-term contingency. Response, then stimulus change, then increased future responding. The stimulus presented as a consequence and responsible for the increase in responding is called positive reinforcement. Positive reinforcement does not strengthen the response that just occurred. The response has already happened and cannot be altered. What changes is the future probability of responses in the same operant and response class. Reinforcement operates on the operant as a class of behavior. It is not correct to say reinforcement strengthens a single past response. It changes the likelihood that responses of that class will occur again. Rate of responding was used as the fundamental datum in early research, but reinforcement can also alter duration, latency in response time, magnitude, and topography. If reinforcement is delivered only when responses fall within a certain magnitude range, responses within that range increase in frequency. Reinforcement also alters antecedent stimulus conditions by being temporarily paired with response reinforcer contingency. Antecedent events acquire the ability to evoke instances of that reinforced response class. A discriminative stimulus, or SD, is an antecedent stimulus correlated with the availability of reinforcement for a particular response class. Responding in the presence of the SD produces reinforcement. Responding in the presence of the S delta does not. With the addition of the SD, the two-term contingency becomes the three-term contingency of the discriminated operant. SD response reinforcer. Through this history, responding occurs more often in the presence of the SD than in the absence, and the behavior is under stimulus control. Reinforcement does not require awareness. A person does not need to understand or verbalize the relation between action and consequence, or even be aware that a consequence has occurred. For reinforcement to take place, the reinforcing connection need not be obvious to the individual's behavior who's being reinforced. Reinforcement occurs because of the functional relation between behavior and environmental change. Negative reinforcement is defined by a different kind of stimulus change. A negative reinforcement contingency is one in which the occurrence of a response produces the termination, reductions, postponement, or avoidance of a stimulus, and that change leads to an increase in the future occurrence of that response. A full description includes four components: an establishing operation for behavior maintained by negative reinforcement, a discriminative stimulus signaling that escape or avoidance will be reinforced, the response that produces reinforcement, and the reinforcer, which is the termination of the event that served as the establishing operation. Positive and negative reinforcement have a similar effect on behavior in that both increase responding. They differ with respect to the type of stimulus change that follows the response. In positive reinforcement, a stimulus that was absent prior to responding is presented. In negative reinforcement, a stimulus that was present prior to responding is terminated, reduced, postponed, or avoided. Many stimulus changes have discrete onsets and offsets and can be described as presentation or removal. Others exist on a continuum, making classification less straightforward because of the ambiguity of some stimulus changes specifying the environmental transition between pre-change and post-change conditions clarifies the functional relation between behavior and environment. Negative reinforcement commonly involves escape avoidance contingencies. In escape, a response terminates an ongoing stimulus. For example, when a rat presses a lever to turn off a bright light, the response is reinforced by termination of the light. In applied arrangements, completing a work requirement may terminate the requirement. Escape contingencies involve removal of a stimulus already in effect. Avoidance contingencies involve preventing or postponing the onset of a stimulus. Indiscriminated avoidance responding occurs in the presence of a signal that precedes the aversive event. Responding in the presence of that signal prevents the event from occurring. The signal functions as a discriminative stimulus because responding in its presence is reinforced, whereas responding in its absence is not. In free operant avoidance, responding occurs without a specific warning signal. The response delays or resets the interval before the aversive stimulus occurs. In both arrangements, responding increases because it produces postponement or prevention of the stimulus. Research comparing escape discriminated avoidance and free operant avoidance contingencies demonstrates that these distinct arrangements of negative reinforcement. In each case, behavior is maintained because it produces termination, reduction, postponement, or avoidance of a stimulus, and the future likelihood of responding increases. Reinforcement is defined strictly by its effect on future responding. Positive reinforcement presents a stimulus, negative reinforcement removes or prevents one. Both increase behavior. If future responding doesn't go up, it wasn't reinforcement. It's that simple. Let's keep it going. Brain tap.